Hi, in this previous video, you have learned about um, a bit about how frame is encapsulated. Now let's look in details on the data encapsulation part of the network communication. So let me change the pointer options first. So in network communication, in network segmenting is the process of breaking up message into smaller units. In data communication and networking subject, you have learned how multiplexing will taking multiple streams of segmented data and interleaving them together. So there are two primary benefits of segmentation. First, to increase the speed, because if you, for example, if you communicate or sending a video or an audio over the network, so the large when we need to break the messages or the information into a smaller unit so that the speed is increases. Hence the reason, if you look that any application, like for example the email has certain limits of file size to be submitted or to be sent over the network. And then it increases efficiency, so only segments which fail to reach destination need to be retransmitted, not the entire data stream. So in the data segmentation, we use the technique sequencing. So sequencing is the process of numbering the segments so that the message may be reassembled at the destination. So for example, during the segmentation, if you are sending video or file which size is 10 megabytes, so the size or the file will be break into several pieces of messages. So all of the messages will be numbered so that we know that in the network you may use a single or many path to go to the destination. So in order for the message to be reassembled, so we need a number or sequence number so that the individual segments can be reassembled at the according to their order at the destination. And then next terminologies is encapsulation. Encapsulation is the process where protocols add their information to the data. So at each stage of the process, a PDU has a different name to reflect its new function. So PDU is protocol data unit. So for example, first when you are emailing a data, like for example a file, so we call the PDU as data. And then when you go to you pass down the TCP/IP suite or TCP/IP stack, so more information is added to the header of the data. For example, here data, so we add a transport header, and then in transport layer we call it, no more calling it the PDU as data, we call it as segment. And then when the segment pass down to the stack to the network layer, so a new header is added. So now the PDU unit is no longer called as segment, we call it as packet. And then when the packet is passed down to the lowest layer, the lower layer, which is the network access layer, so a new frame is added, which is frame header, and we no longer call the protocol data unit as packet, we call it as a frame. So what are the information that are added to the header? I have shown you earlier here. So this is the data, for example, the file that you email, and then we encapsulate it with the TCP header, and then in the network layer we encapsulate with IP header, and finally we encapsulated the frame with Ethernet header or the MAC address So this is the encapsulation, or we have the diagram in the next slide. So this is the process of encapsulation example. Encapsulation is a top-down process. So the level above does it process and then pass it down to the next level of the model. So this process is repeated by each layer until it is sent out as a bit stream. So on the receiving end, on the destination, the data will be de-encapsulated and moves up the stack. So, for example, first you receive the data as the bit stream, and then you decapsulate it and read the header information and the frame, and then decapsulated and read the IP information as a packet, and then decapsulated the segment, and finally you will get to read the actual data. So let's see the interaction between TCP/IP layers. So this is the these two part. This diagram is the layers for OSI. But because the reference model in practice that we use TCP/IP model, so you can see here a more accurate representation here. So for the network access, it consists of data link and also physical. For the network, we have IP, ICMP, and also ARP protocol. This is just the example, the example of protocol. And then for transport, we have TCP, UDP, and the application, we have HTTP, FTP, DNS, and also POP3. POP3 is for email, DNS for DNS service. So as the PDU pass down the layers, so each of the PDUs will be encapsulated with the different headers according to the layers. So you can see here for this interaction has been explained earlier on. So for the application layers, the application message, the file itself, and then transport, encapsulate the message with TCP or UDP. If you are using TCP, we call it as segment. The PDU is called as segment. But if you are using the UDP, the PDU is called as datagram. And then on network layer, encapsulate the message again with the IP packet, and the outer header is the Ethernet frame before the frame is being transmitted at the physical layer. So this is the interaction between the sender and the receiver from the original actual messages, and you can see that all the messages has been encapsulated at the sender when it is passed down to the TCP/IP layer, and at the physical layer the message is decapsulated so that the receiver can read the actual message. So for the interaction just now, this is the interaction between layers with the assumption that the sender and receiver sits in the same network. Sit in the same network, both sender and receiver. So meaning device A and device B sits on the or located in the same network. But if device A and device B does not is not located in the same network, where in between of them they are intermediary nodes, like router, meaning there sits on different network. This one is network A, this one is network B. So the interaction between layers in the TCP/IP model is a bit different. So the diagram shows how data travels from device A to device B through several network devices. So you can see that this network device indicate that this is a router, and you need to know that if the network is connected, if the device is connected to a router, means you already have two different networks. Okay, so the communication is organized into 5 layers here, but you know that the one in yellow in the TCP/IP model is actually the same layer, network access layer. Okay, so the sending device processes the data through all the layers before transmitting it. But what happened here in the in the intermediate devices, they only use the network, data link and physical to forward the data. So for device A, the encapsulation happen from application until the physical, but when it goes to the intermediate node, here in they will read the network header information, the IP header information, and see when you decapsulate. So you will see whether the packet is intended for the network or not. So because this is only intermediary node, so this is not the intended destination, so the packet will be passed down again to the next intermediary node. So you can see that on the intermediary node, the encapsulation process does not happen on the transport and application layer because the packet will be passed to the next intermediary node until it arrive at the intended destination. So when it arrives at the intended destination, then decapsulation will happen on the transport and the application layer on device B. So that's all for today. I hope that you will take a good introductory lessons in this chapter. Thank you.